In this video, we will go over several examples of using the definition of a base raised to a fractional exponent. So we have several examples here. Fractional exponent can be rewritten as a root. The root has to do with the number in the denominator. So in example A, we have 49 to the 1/2 power. That's the same as the square root of 49, which of course is 7. Now here we're talking about the principal square root, so we don't need to worry about plus and minus. It's just positive 7. For example B, there's two things to think about. The first is, what does that 1/2 power mean? And what about the negative sign in front of the 144? Remember that that negative sign doesn't have anything to do with that exponent. So this is the same as the negative square root of 144, which is then a negative 12. Part C is actually identical to part B. In part C, it's very clear that the 1/2 is not applied to the negative sign in the front. So B and C are the same value because they have the same meaning. In part D, it's not the square root, it's the 6th root because the number 6 is in the denominator. So what number times itself 6 times is equal to 64? That turns out to be 2. Now part E is not a real number because we're asked for a number that can be multiplied by itself 6 times to equal negative 64. That negative does belong to the root part, to the exponent. Since we're multiplying a number by itself an even number of times, we cannot get a negative outcome. So part E is not a real number. It's not no solution. There is a solution. It's a complex number. It's an imaginary number, not a real number. Part F may look the same as part E, but it's different. That negative kind of hangs out in front of the base, the 64. The 1/6 power doesn't have anything to do with the negative in the front. So in this case, our answer is negative 2, because 2 times itself 6 times is equal to positive 64, and the negative is just along for the ride. Now part G is different than part E because of the root. In part E, we had a 6th root. In part G, we have a 3rd root, a cubed root. What number times itself 3 times is equal to negative 125? That does have an answer. Negative 5 times itself 3 times is negative 125. In a similar way, H also has an answer. Negative is on the outside of the root. The 1/3 power doesn't have anything to do with the root, the cubed root of 64. So our answer is negative because our original problem had a negative in it, and the number times itself 3 times that equals 64 is 4. Now, what happens when the exponent isn't 1 over something? In all these examples, our exponents are not 1/4, 1/6, 1/2. They have something other than 1 as a numerator. So we need to know what that means. 81 to the 3/4 is the same as 81 to the 1/4 to the 3rd power. So split up the exponent into 2 pieces. One piece is a fraction 1 over whatever your denominator is. The second piece is another exponent. So we look for the cubed or the 4th root of 81. What number times itself 4 times is equal to 81? That's 3. Raised to the 3rd power gives us 27. For part B, we split it up into 25 to the 1/2 power to the 3rd power. Now 1/2 means square root. So this is the square root of 25 to the 3rd power, so 5 to the 3rd power, or 125. Part C, remember that negatives in front of the 4 is separate and apart from the term with the exponent. So we think of this as negative, parentheses, 4 to the 1/2 power to the 5th power. 4 to the 1/2 power is the square root of 4. So this is negative 2 to the 5th power. 2 to the 5th power is 32, so now I have negative 32.